Okay, team challenge number 2 was about figuring out pHs of weak acids. So in the question, you're given a pH of 2.8 for a 21 millimolar solution, and you have to figure out what the Ka is. So, what do we know? We know the pH. The pH of 2.8 it allows us to calculate what the hydrogen ion concentration is. It's 10 to the negative 2.8, which is 1.58 times 10 to the minus 3 molar. All right? So we know what H plus is. Remember that the equation we're working with here is HA goes to H plus and A minus. All right? And so our Ka is the concentration of H plus times the concentration of A minus all over the concentration of HA. We can calculate how much HA we have left because we know that we had 0.021 molar to start, and then 1.58 times 10 to the minus 3 are now as A minus and H plus. So it turns out that that leaves us with 0.0194 molar as HA. So our Ka then is going to be equal to 1.58 times 10 to the minus 3 molar squared over 0.0194 molar, which gives us a value of 1.29 times 10 to the minus 4. Okay, what is the percent ionization here? We need the amount that is ionized, and we figured that out using the pH. So our percent ionization is equal to the concentration of A minus over the concentration of HA initially, not at the end, but initially. And that is 1.58 times 10 to the minus 3 molar divided by 0.021 molar. And this comes out to times 100%, of course, times 1 essentially, equals 7.5%. So one of the things that should jump out at you with this problem is that if you had made the 5% rule assumption, you would be off by a couple of decimal places because the 5% rule doesn't apply here. You've shown that it's 7.5%, so your math would be out if you had done that this way.